All right, guys, our next lesson is on solving absolute value equations. So I'm going to start with right here, kind of a review of absolute values. Um, what's the difference between a 6, absolute value of 6, and an absolute value of negative 6? And the answer is the absolute value of 6 is 6, and the absolute value of negative 6 is also 6. There is no difference. There is no difference because because absolute value is the distance a number is from 0. Number is from 0 on a number line. 6 and negative 6 are both 6 units away. Okay, so that's what we have to think about, away from 0, I should say, technically. Okay, so whenever we're talking about absolute values, we can think of both sides of 0, positive and negative. That's going to be really important because they're all still the same distance, and distance is always positive. All right, so when we see absolute value equations, here are the steps that we want to use to solve. Number 1 is we want to isolate the absolute value. I wanted to use blue. Isolate the absolute value expression. So we're looking just for what's inside the absolute value. We want to isolate that first. So we may have to manipulate the equations a little bit to get that, but we will. Now you're going to set up 2 cases after you've isolated it. One case is going to be the same. That's going to be your positive case. And then the second case, you're going to change all the signs on the, it already says on the non-absolute value side of the equation. And I will show you what that means. Pretty much means we're going to separate things into positives and negatives because they're all the same distance away from 0. All right, and then we have to, after we're done with that, then we solve both equations, but we solve them separately, which means we can get 2 possible answers, okay? But what we also have to think about is we have to check for, and this is something new vocabulary for you guys, we have to check for extraneous solutions. Extraneous solutions. Those are solutions by substituting, and you do that by substituting back into the original equation. That's the original absolute value equation. Okay, and that's what we're going to look for, is to see if one of our, or if both of our examples are even possible. And so we'll talk about what that means right here. That's what we're talking about. There are 3 types of solutions that we can get with absolute values. We can just get definite solutions. So here's what an example of that looks like. I can have an absolute value of, say, 7x minus 4, and that's going to equal 8. I'm going to get 2 definite solutions here. One for a positive 8 and one for a negative 8. Okay, now that's going to be 2 solutions. So this is, I would say there's 2 solutions here. Possible solutions is when I have an absolute value expression like 3x minus 2, but it's equal to another variable expression. This could be 2, there could be 2, or only 1, or none. So 2, 1, or none solutions. So this one, these are the ones you definitely need to check for the extraneous solutions. And then some of them, they have 0, you don't have any solutions at all. And that's like if I have an absolute value expression equal to a negative answer, like a -1. Anytime it's equal to a negative answer, that's not possible because absolute values are always positive because they're distance away from 0, and distance is always positive. So if I ever get an absolute value that equals a negative, there's no solution. There's just no way. It's impossible to do. Okay? So what's the difference between each possible case? What's the difference between all these possible cases? Okay, so we always need to isolate the absolute value first before identifying our solutions. So really quickly, if I'm looking at the definite solution, the non-absolute value side, so that's like the 8. See, that's the side that's not the absolute value. If that's going to be a definite solution if the non-absolute value side is a positive number with no variables. With no variables. Okay? That's the case. I'll always have 2 solutions. We'll always have 2 solutions here. That's what we're going to get. Okay? To get this one in the middle where it's possible solutions, the non-absolute value side, that's this side here, has a variable in it. So that means that we definitely need to check. We need to check. For extraneous solutions. Because we don't know what that x could be. When we solve for x, we don't know if it's going to make it possible enough. So extraneous US solutions, okay? And then for this one, for the last one, for no solutions, it's if the non-absolute value side, that's right here, is a negative number. Negative number with no variables. Okay? With no variables. It's not true. It can't happen. It's not possible. Not possible. Okay? It's not possible. It cannot be true. All right. So let's just go through and let's just go through and solve these and see how we're going to write our answers, because we're going to write our solutions a little bit differently because they're a set. Number 1, isolate the absolute value. The absolute value is isolated in this first example, the absolute value of x minus 6. So all I need to do is separate this into its two possibilities. One possibility is that x minus 6 could equal 3. The other possibility is x minus 6 could also equal negative 3. Think about it. It's negative 3 can equal, the absolute value of negative 3 can equal 3, or the absolute value of positive 3 can equal 3. So whatever's on the inside could be positive or negative. That's what we're testing here. All right, so all you're doing is you're solving these two separately. So my first possible answer is x could be 9, or if I add 6 to both sides here, I could get x equals 3. I do not need to check these because there's no variable on the there's no variable over here on the non-absolute value side. So the way we would write this, you could leave it like this. We could just say x equals 9, or x could also equal 3. But we're going to use set notation because it's actually a set of numbers. Oops, not negative. So we'll say it's these fancy curly braces. It's 9 and 3. So that's how we would write our answers. So 9 or 3. All right. So you try the same thing with this one. Our absolute value is already isolated. The 5 plus 4m is isolated. So you don't have to do any extra work in the beginning here. All you need to do is separate it out into 5 plus 4m could be a positive number, which is 45, or 5 plus 4m could be negative 45. So then you would solve those. So go ahead and solve those. Let's see what we get. And then we'll work through some of the other problems on the other side of this paper. All right, let's see what you got. I'm going to subtract 5 from both sides. I get 4m equals 40, so m has to be 10. And x be 10, and then I'll do the same thing over here. We'll subtract 5 from both sides. Now 4m is equal to negative 50. And when I divide by 4 on both sides, I'm going to leave this as a simplified fraction, so it's going to be negative 25 over 2. Don't have to change it to a mixed number. I'm just going to leave it. My two possible answers are 10, 10, negative 25 over 2, and those are my two possible answers. Yes, we can have fraction answers. Okay. So, some other situations that could come up, like this next one, number 3. Are we going to do all of these? No, but we're going to be working through quite a few of them. All right, so the more examples you see, the better this will be for you. All right, if I look at number 3 here, this is my, I think I need to make that smaller. This is my absolute value expression. If you notice, it has a multiply by, if I zoom in, multiply by 7 in front of it. It's not isolated yet, so we need to isolate it. Okay, so how do I undo multiply? So this is that whole manipulating equations. You undo multiply by dividing. So I'm going to divide on both sides. And now I have the absolute value of negative 8r is equal to negative 56 divided by 7 is negative 8. And I can look at this right now, and I already know that there is no solution. This one has no solution. And the way we would write that with these braces, you could actually write no solution, or you can use this symbol that means empty set. That means there's nothing that'll work. But what's the reason why there's no solution? There's no solution because absolute values cannot be negative. Because absolute values cannot be equal to a negative. That looks weird. Cannot be equal to a negative number. So no solution. Negative number. So if you get an isolated, it's got to be an isolated absolute value. If it equals a negative number, no other work needs to be done. There's no solution. Okay? Let's try number 4. What would you do to get your isolated, not variable isolated? This time we're talking about our absolute value isolated, right? That's what we need isolated. Then I can do the splits. So splits, that sounds funny. Now then I can split it up into its two possibilities. So if that's a plus 7, we need to subtract 7. So what I'm left with is the absolute value of negative 8n plus 8 could be equal to 24. This will have a solution. It will have two solutions, right? So it'll have two solutions. So I've got to split this up into what's inside the absolute values, negative 8 plus n, equal to a positive 24. Or negative 8n plus 8 could be equal to a negative 24. And then we would solve these two. All right. This one becomes n equals negative 2. This one becomes n equals 4. So this could be negative 2 or 4. Those would be our answers. Okay. I'm going to move us on to extraneous. The ones we have to check for extraneous. Remember, those are the ones that have, if I double check that, those are the ones that have a whole variable expression on the other side, not just numbers on the other side. Okay, so I'm going to look at number 7. We're going to jump down to number 7 here. Number 7, see how I have two of these here. I don't have to work on isolating because this is already my absolute value expression is already isolated. So I'm going to now separate this into its what the two possible answers could be. So, or answers, two possible equations. So 3x minus 4 could be equal to a positive 2 times 3. That should be a 3x minus 5. Or what's inside the absolute values, 3x minus 5 could be equal to a negative 2 times 3x minus 5, right? That whole thing is, well, technically the whole thing is negative, but we can say it as a negative 2. All right? So if I go through and solve all of these, I get, if I distribute, I get 6x minus 10, 3x minus 4. I'll subtract 6x from both sides. I get negative 3x, but at the same time, just to save me some space, I'm going to add 4 to both sides. So I get negative 3x equals negative 6. So x could equal 2. Okay, that's the first one. On the second side, when I distribute, this could be negative 6x plus 10. That's 3x minus 4. When I add 6 to both sides, that becomes 9x. And then I could, at the same time, add 4 to both sides. So those all go away. So I get 9x equals 14. So this is going to be a nice one. X could equal 14 ninths. Woohoo! Okay, I have to check both of these now to see if they work in the original. Okay, so we're going to check here in the original equation and see which, they could both work. Maybe only one of them works. Maybe neither of them work and we have no solution. So we have to do a check. Let's do a check. So here's our check. I'm going to start with the x equals 2. So I'm going to check x equals 2 right here. I'm going to split things. Hopefully I have a little bit, well, it's right, kind of tiny. So the original is the absolute value of 3 times x. So that's 3 times 2. Then we subtract 4. So that's a substitution. Equals 2 question mark, does it? 2 times, and then you have 3 times whatever x is. So remember, your substitution is 2. Wherever you see an x, you put a 2. Minus 5. So this right side is 2 times 6 minus 5. That's 2 times 1, which is 2. So we'll see if the other side equals 2. The absolute value of 6 minus 4 is the absolute value of 2. The absolute value of 2 is 2. So 2 is actually one of our solutions. So this one checks out. 2 does equal 2. All right, 14 ninths. This one might be a little bit trickier because of the fraction, but it's doable. So I'm going to substitute it back into the original, the absolute value of 3, and then I have to put in 14 ninths in place of x, and then minus 4. That has to be, is it equal to 2 times 3 times, now we got to put in that 14 ninths, and then minus 5. Okay, so remember this is where I'm substituting back into. All right, I'm going to do some quick cross-canceling. This becomes a 3, that becomes a 1. This is the absolute value of 14 thirds minus, I'm going to change this to have a common denominator, so it's going to have 12 over 3. 14 thirds minus 12 thirds is 2 thirds. So I know the answer here is 2 thirds. And then we'll double check and see if the other side is equal to 2 thirds. All right. This is also going to be 14 thirds. So this is 2 times, this is going to be 14 thirds. And now I'm going to change this to have 15 thirds. This is 2 times, that's going to be a negative 1/3. And what I have here is negative 2/3. Do you see how these two are not the same? That's a no-go. So this is what we would call one of the extraneous solutions. So the answer cannot be 14 ninths. So the only answer that works is the 2. All right, so there's a lot of extra work involved. And this one was a little bit harder because of the fraction part. Okay, so what I'm going to have you guys try is right now is one without a fraction. I want you guys to check the extraneous solutions. So that would be number, let's try number 9. I want you guys to try number 9, okay? It's already isolated for you, so you can test that out. Okay, so you try number 9, see what you get. Is there an extraneous solution? Do both of them work, or does only one of them work? Check it out. Pause the video. Okay, we're back. Let's see what happens. I'm going to, I know that 2 absolute, no, it's already by itself. So I can turn this into 2t minus 3 could equal a positive 3t minus 2. Or what's inside the absolute values could be 2t minus 3 equal to a negative 3t minus 2. So notice I put the 3t minus 2 in parentheses because it's the opposite of the whole thing. All right. Let's go through and solve this. This is going to be negative t equals 1. So t equals 1 on this side. Negative 1, sorry. If I divide by negative 1 on both sides. That one should be negative 1. My bad. And then this one, I got to distribute. So this is going to be negative 3t plus 2. This is 2t minus 3. So when I add 3t to both sides, I get 5t. Add 3 to both sides, I get 5. This one is t equals 1. So this one's going to be a little bit easier to check. Okay? But we need to check them because I've got variable expressions on both sides. So we're going to do our check. Check, check, check. Now remember, you check into the original absolute value equation. So we're going to check t equals negative 1. So the absolute value of 2 times negative 1 minus 3, is that equal to 3 times negative 1 minus 2? All right, so 3 times negative 1 is negative 3. Negative 3 minus 2 is negative 5. Okay, so we're going to see if the absolute value part becomes negative 5. And actually, we already know, because anything in absolute values has to be positive, doesn't it? So I really don't have to do anything else. This is going to be 2 minus, well, and it becomes negative 2 minus 3. The absolute value of negative 5 is not equal to negative 5 because it's equal to 5. It's a positive. So these are not going to work. This is extraneous solution. So this one's not going to work. Remember, anything in absolute values has to be positive, not negative. Okay, so that one doesn't work, but let's double check the other one. The t equals 1 might not even work. So back to the original, we're going to check it. Absolute value of 2 times t, which is 1. And then we subtract 3, and then close our absolute values, equals 3 times t, which is 1. And then we'll subtract 2. This is going to become, on the right side, 3 minus 2 equals 1. On the left side, this is the absolute value of 2 minus 3. The absolute value of negative 1 does equal 1. This one does work. So the only solution that will work on this problem is is t equals 1. That's how absolute values work. Okay? Some of the things you need to remember is you've got to isolate the absolute value symbol. or expression. So if I look at number 10, that is not isolated. So I have to think about, how do I manipulate this equation to isolate it? Think about that first. Go ahead and think about it. All right. Hopefully this is what you thought of. I need to add 3 to both sides. Okay, I need to add 3 to both sides to move that 3. I'm left with 2 times the absolute value of x plus 1 equals x plus 1. And then I still have 2, divide by 2 on both sides. So this is a divide by 2 on this whole thing right here. So the absolute value of x plus 1 is equal to x plus 1 divided by 2. This is what I would use to separate them out. So into their two parts. So you could have inside the absolute values could be just positive, or inside the absolute values could be, this is where you have to be careful, it's a negative x plus 1 in parentheses over 2. So there's going to be a distributive property here. All right. So then you would go through and solve this. I would solve this by multiplying both sides by 2 on both sides, like that. So the 2's cancel out. I get 2x plus 2 equals x plus 1. From here, I get x equals negative 1. So one side is x equals negative 1. And then on this side, what we get, x plus 1 equals, oh, you know what? Let me do the multiply by 2 thing first. I'm going to multiply by 2 on both sides. Multiply by 2 on both sides. So I get 2x plus 2 equals the opposite of x minus 1. So if I add x, I get 3x. If I subtract 2, I get negative 3. They're both the same answer. So I get x equals negative 1 either way. So I only have to check x equals negative 1. So that's all you have to check. If you only get one answer, that's all you got to check. So I'm going to check it into the original right up here. 2 times the absolute value of negative 1 plus 1. Absolute value. Then we subtract 3 is got to equal x minus 2. Sorry, I don't make it look like this. 2 times the absolute value of 0. Right? 2 times the absolute value of 0. Oh, I guess I didn't have to go that far, but I will anyway. Minus 3 equals x. Oh, x is negative 1. Sorry. It's negative 1. Negative 1 minus 2 is negative 3. If I add 3 to both sides, I get 2 times 0. 2 times 0 equals 0. That works. So my negative 1, which is my only answer, works. All right. A lot of information on this. Absolute value equations. I know they're new, but I know you guys can do it. All right. Have a great day. We'll talk to you later.